So we'll start the class in a minute. Good afternoon, students. Welcome to prestigious IIT and NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students of Ramannapeta branch, Panuru branch, and Kishanbag branch. So far, for today's session, as you can see on the screen, and you are well aware. So my subject is physics. We are in class 9th, our ongoing chapter, units and dimensions. And today we are entering into the session number 5. So far we completed the 4 sessions in discussing about the basic concepts of units and dimensions, which comes out from measurements. It's a part of measurement. It is a part of measurement. Welcome, Gopal Nagar. So while starting with the recalling 6th, 7th, 8th knowledge, we are entering into the units part, then into the dimensions part. Right. But before we'll continue where we left in the last class. But before that, once again, I remind you, gentle reminder for you all. Right. So gentle reminder about the monthly examination. As you all know that there is every month, last Monday, we'll have examination for IIT Foundation, so that you can motivate the students to appear for examination. This time, we are providing a special badge for the IIT topper also, like how we are providing for signature programs. So encourage the students to prepare well before attending the examination. So that first examination, due to unavailability or late receiving of the data, student data, we are able to send the question papers in time. The question paper, physical question papers or hard copies will reach your branches by Tuesday or maximum by Wednesday, so that you can conduct examination on 1st August, that is Thursday. Plan to conduct the exam on 1st August as per the receiving of question papers, right? That's the first point. This question paper contains multiple choice questions, MCQs, as you know, and also we'll provide you OMR sheet. You have to write only on OMR sheet. You have to bubble it. Bubbles you have to do. And you have to mention your student ID. Already we have provided a student ID for all the branches. So write the student ID and write the answers on OMR sheet and send your answer sheets to the address given to you. They'll give address for you where to send it, so that they will do the corrections through OMR machine and will send the total branch report within 1 or 2 days to your branch, right? So that you can analyze it. You can analyze the performance of your students, and we will analyze all the branches reports, right? So motivate the students. What is the importance of these classes? That is the work of the teachers. Remaining work we'll do from here. Only thing the teachers, subject teachers, is you have to encourage the students how important these classes are, how important IIT Foundation for their future, right? Okay. Now, when you move to what we covered in the last session and what we are going to cover in the today's session. So these are the topics what we covered in the earlier sessions. We covered starting from review. We recalled 6th, 7th, 8th class, what we learned about measurements, physical quantity, and how the physical quantities are classified into fundamental and derived quantities. Then what is unit? What is the importance of units? What are the rules of writing units? Then we enter into a new part called dimension and dimensional formula. So that last 2 days we are discussing about the dimensions and dimension formulas and what is the importance of dimension formula. What is the applications of dimension formula in physics? How far you can use the dimensions in the physics and how easy for us to do some works with the help of the dimensions, right? So just we recall before going for the today's session, right? So remaining all same only about the measurements, physical quantities, fundamental quantities, derived quantities, all you learn in earlier classes. But what is new is dimensions. This is about the unit, a standard measurement of any physical quantity. And there are some conventions or rules to write the units. You have to follow that rules, right? So these are the prefix using the units and some conversions we have seen. Dimensions we entered. So dimensions are nothing but the powers. Powers over the fundamental quantities. Fundamental quantities are used as a base quantities, and the powers are called as dimensions, and entire representation is called dimensional formula. See, velocity dimension formula is L1 T1, T minus 1. Acceleration is L1, L nothing is there means 1 you can write it. L1 T minus 2. Momentum M1 L1 T minus 1. Like that you can have the dimension formula of many physical quantities we have seen in last class. Okay. So these are the various dimension formulas: area, volume, density, speed, velocity, many more. Okay, power, work, pressure. There are some dimensionless quantities are there, like trigonometric functions, ratios, logarithms, and mere numbers, pure numbers. They does not have the dimensions. Ratios, trigonometric functions like sine theta, cos theta, tan theta, and other cosecant and all. Logarithms also functions. Some constants does not have the dimensional formulas. They are called dimensionless quantities. The physical quantities which does not have dimensions are called dimensionless quantities. Right? Because that is exemption. That is a limitation for dimensions. Okay. Some limitations are there for dimensions. Right? Some variables does not have dimensional formula, which can vary. Okay. And some limitations we have seen. There are some physical quantities having same dimension formula. See, there are there. Quantities having same dimensions. Very important. Same speed, velocity is there. We don't have same on distance by time. So definitely but dimensions are same. Energy is there. In that energy, again, potential energy, kinetic energy. All same only work. All the forms of energies will have same dimension formula. Okay. Gravitation, specific gravity, relative density, they have same dimensional formula. Okay. And the dimension formula is applicable. Applications. When you see applications, what we can get with the dimension formulas? You may get doubt. So what we can do with this dimension? So see, these dimension formulas we cannot use in our regular life. Neither you can use in kitchen, nor you can use school, nor you can use in the bedroom also. It is not like fan, switch, tube light, or heat, gas stove, not like that. They are useful for us in our education, that is in physics, to solve some problems or make the problems very easy. Right? To make our problems easy, you can use the dimension formulas. So for example, so dimension formulas are also called as dimension equations. So they are useful for checking the correctness of physical equation. If any mathematical formula or physics formula you know, but you got doubt whether it is correct or not, you can check by using the dimensional method. By checking if LHS is equal to RHS, left hand side dimensions are equal to right hand side dimensions, then you can say that the answer is correct. For example, I'll tell you. Yesterday I told already F is equal to MA. Now V is equal to N lambda. I'll tell. This is a formula in sound. You might have seen. So V is that word velocity. Velocity is M1 T minus 1. This is the dimension of M0. You can write. That is LHS is M0 L1. N is that word frequency. Frequency's formula is given by 1 by T or T minus 1. Lambda is nothing but length, wavelength, L. So LT minus 1, LT minus 1. That means this formula is correct. Means LHS is becoming equal to RHS. When LHS is equal to RHS, there are some examples are given for you in material. You can check. Both sides are correct. You can find this. Similarly, the second one is to derive the new equation. We know some quantities, physical quantities. So, for example, T is equal to one formula is there, 2 pi under root L by G. That formula is there. Okay. Let me get. So this is formula for time period. Time period. Here, how many quantities are there? T is there, L is there, G is there. 2 pi is a constant anyway. Constant does not have any. So T is nothing but time period. The dimension formula is T1. L is nothing but length. L1. G is nothing but acceleration. L1 T minus 2. Right? This is the dimensional removal. So what we have to write is, we know only T, L, G. We don't know the formula. We are deriving the formula. We can write T is directly proportional to LG. We have to write like this. So whenever you are know the only physical quantities and you want to find the relation. So left hand side, you can take this side. Right hand side, whatever is there, you can take directly proportional like this. So this is just a constant you can write. So T is given by, you can write T, you can write as. So you can write T is equal to L by G. So T, you can write T into time period is T1 is equal to, in place of proportional symbol, you can write 2 pi. 2 pi I written. So then, okay, L1. L1 I wrote. L place length only na? L1. And G, in place of G, L1 T minus 2. In place of G. So what you can write? T1 is T is equal to 2 pi. L into L, L square. L square, take T minus 2 to denominator becomes T square. L square by T square. So T is equal to 2 pi. L square by 2, you can write like that. L by T. Sorry. L by G. Sorry, not T square. G. So formula we can get like that directly. Whole square you can write. Or root you can write. So you can write in place of L, you can get L by G. L T square. L by T square. Means by knowing the physical quantities. There are some examples are given, I'll show you. By knowing the physical quantity, we can deduce the relation or you can find the new equation for the physical quantities. That is the second important point. There are so many examples you can learn in the 11th class. When you go to 11th class, this chapter, first chapter is this one, units and dimensions, where you can give so many examples, so many formulas you can derive by knowing that physical quantities. Then convert, we can convert the CGS into SI or MKS into CGS or CGS into MK. That is also one of the important application. So for example, 1 Newton. 1 Newton is equal to 10 power 5 dynes. Or 1 joule is equal to 10 power 7 erg. How you got this relation? This relation you can obtain by using the even. There is a different method is there, but by using dimensions also you can calculate. That method is not important for you right now because this is important in the 11th, 12th classes to get examination, how to derive them. Just you can go through your material, you can find that. So these are the 3 major applications of dimensions in our physics. Okay. Apart from that, there are other possibilities also there. That 4th one you can see. Identifying the physical significance of constant. If any constant is there like 2 pi or other constants, what is the importance of that? We can analyze that by analyzing the dimension of constant equation. So by analyzing the dimension of constant in the equation can be analyzed here. So simplify the complex equations to simple equations. By using dimension formula, the complex equations can be converted into simple equations and then you can solve it. Right. So identify the type of physical quantity. Which physical, by seeing that only, for example, it is given L1 T minus 1. So what is the physical quantity if you ask? So what you can write? L1 by T. That is length by time, distance by time. So what is distance by time? Velocity. So by seeing the dimensional formula, we can identify the physical quantity. That is a very important part. Check the consistency of the physical theory. So by verifying the dimension of the theories, equations are consistent with experimental. Means you can prove that the equation is consistent or not by using the dimensional methods.
Excuse
Right.
me, sir.
So
Can't understand.
these are the few applications of dimensions. Applications of dimensions in our physics. The major are three. You can check the correctness of physical equation, derive new equation when you know the physical quantities. You can derive the relationship between the physical quantities. That is the mean. When few physical quantities are given, you can deduce the relation. We can convert the one system of unit into another system also. Or you can find the relationship between one system to another system. Using this, these are three major applications of dimensions. So dimensions, dimension equation, the dimensionless quantities, right? We have seen. Then we have seen the what are the applications of dimension, what are the limitations of dimensions also. We have dimensions only for the physical quantity, the equations having three physical quantities. If it is more than three, we cannot go for the dimension formula. Or we cannot go for the checking. Like that, there are some limitations also there. Some limitations are there. So many things are there. Okay. For the this one. So before going for the next, let us after this we have some worksheets are there because we have the examination. So examination for keeping exam, that is theory part is completed. So theory part is completely done. Total explanation part is completed. Now that is ball is in your court. You have to read. You have to read the material starting from physical quantities to the dimensional applications of dimensions. So around page numbers up to so many are there. You have 19 pages are there totally from 9 to 19. So you have to go through from page number. The lesson starts at page number 9 to 19. Right? Page number 9 to 19, we have the chapter number 1. So before that, there is a 0 chapter is there that we'll discuss at the end. Page number 9 to 19, 19, you have to go through complete explanation of what is physical quantities, types of physical quantities, units, dimension formulas, dimension formula of various physical quantities, and dimensionless quantities, limitations of dimensions, and applications of dimensions. After reading all these, after preparing with this, then you have to go for the worksheets. These worksheets are classified on synopsis 1, 2, 3. We have 3 synopsis levels. You see, in that also again we have level 1, level 2, level 3, level 4 standards. So keeping the view of the all the competitive examination within the school and after the school. So we are given the standards in the form of levels. You can see here. So first part, if you see here, so one important thing is before starting, I'm telling, we provided to your teachers all the solutions are key for the entire material. Entire material is key. See, for example, see here. This is the key for the first chapter. So I'll explain later. Key is provided for teachers. I request the teachers to help the students in help answering the questions. Because in this class, I may complete some questions. So remaining may be left. They have to practice at home. They have to practice before exam, right? So for example, see here. First part we have here. Okay. First level 1 question starts. Level 1 mains. Mains and advanced is exam will be there. That mains part is little lower level questions. The based on the topic physical quantity. First what we discussed. A physical properties which can be measured is called physical quantities. So there are 7 questions based on the physical quantities. You have to answer them. See, which of the following system of units is not based on units of mass, length and time alone? So see, MKS is based on the mass level, CGS also, FPS also. But international system is not based on this, only alone. Some others also is considered. SI system. So, which of the following system unit is not based, not you have to be carefully, on units of mass, length and time? All the 3, MKS system, CGS system, FPS system is purely based on only mass, length and time. Whereas SI system is based on, apart from mass, length and the others also, other 4 also. So answer is 1. answer for the first question. You can note down the question also, or you can open your books and you can answer them. So answer is first. SI system is not based on the mass, length and time alone. Question number 2. Which of the following is not a name of physical quantity? Which is not a name of physical quantity. It's not a physical quantity. Right? Displacement is a physical quantity only. Momentum also you can measure physical quantity only. Meter is not a physical quantity because it is a unit.
Bring you money. Just bring Uzma's mobile.
So meter is not a physical quantity. It is a, sorry, for example, just a minute. So meter is not a physical quantity, simply a unit. Even torque also physical. Torque is nothing but force. A force. Suppose when you are opening the bottle, we'll apply the force with the 2 fingers. This force, the couple of force is called torque. That will come across later. So first answer is SI. Second one is meter. Meter is not a physical quantity, it is a unit. Meter is a unit. Next, luminous intensity is measured in terms of. So this is one of the fundamental physical quantity. One of the fundamental physical quantity. Okay. So one of the fundamental physical quantity. And the units are, it is candela. Mole is quantity of substance. Kelvin is temperature. Radian is plane angle. Right. Whereas intensity, the luminous intensity is measured in candela. Next, mole is the unit of. Mole is also one of the fundamental unit of quantity of matter. It's not a unit of distance. It is not a unit of time. It is not a unit of velocity. So what is left here? Quantity of matter. So mole is the quantity of matter. Clear? Fourth one is 3. Okay. Fifth one, dyne second is the unit of dyne second. Dyne is nothing but force. Second is nothing but time. Force into time. Nothing but momentum. So force means only dyne. Energy means joule. Power means watt. Whereas momentum is nothing but force into time. That is nothing but impulse rate of momentum. Is nothing but force into second. Okay. Light year. Light year is the unit of. We discussed already. Year is the name is not time. Light year is nothing but distance traveled by a light in 1 year. Means distance only. It is a unit of distance. Light year is the unit of distance. Clear? Seventh one. The magnitude of any physical quantity. Magnitude is what? For example, mass is equal to 50 kg, you can say. So this 50 is called magnitude. Whereas kg is nothing but unit. So this magnitude does not depend on the any method of measurement. It is a fixed one, constant. Does not depend on the method of measurement. It is not more or less in CGS or MKS. Everybody it's same only. Okay, it is always same. Magnitude is always same. Clear? These are the first level on topic physical quantity. So we'll move a little forward. We'll go for some more questions from the second part. Okay. See here. Question number 8. Question number 8. So what is the dimension of physical quantity of symbols used in mass, length and time respectively? So mass, length and time, MLT. How we represent? Mass, length and time by MLT. Any dimensions of physical quantity symbolically represented by capital letters, not kg, LT, kg, meter, second, ml, s, nothing is there. Only we have to represent by mass, length, time. So option is 3. Right? Mass, length and time. For any physical quantity, when you are writing dimensions, we will represent M, L, T and other fundamental quantities also. So again, the dimension, this is a flux is not given for you, but anyway. So dimension, the dimension of equation of magnetic flux, it is not given here. Flux, it is nothing but density per area. Okay, so density by area. magnetic flux, magnetic density, you can call it as. Density, we know, mass by volume, ml minus 3. Area is nothing but L square. So it given m1, L square goes up, it becomes m1 L minus 5. Because minus 3, minus 2, minus 5, T0. Right, it is not given here. Right? So magnetic density by area, how much area it is passing through, is called a flux. So like that, we can find out, right? Then, show dimension formula as that of energy by mass by length. Energy, mass into length. Similar to what? Ninth question is asking here. Similar to, so 10th question. The physical quantity which has dimension formula as that of energy by mass into length. You can find out easily. What is energy? Again, work only. That is m1 L1 T minus 2 into distance. Energy is nothing but force into distance, L1. By mass is m1 L1. You can cancel out m1 M1, L1 you can cancel. What is left here? T minus 2 L1. L1 T minus 2. So L1 T minus 2 is nothing but acceleration. Like that we will calculate. Dimension formula of volume, 11th one. Volume is nothing but length into breadth into height. That is L cube. M0, L cube, T0. So where it is? First one, M0, L cube, L minus L cube, T0. Okay. What is it given here? 11th. Not given here. No answer here. 11th one answer is not given here. Answer is this one. Okay. Volume, L cube only. M0, L cube, T0. Even key also they give NA, not available given. 11th question. NA means given, not ABC is not given here. All three are wrong only. 4 are wrong only. Answer is L cube. M0, L cube, T0. But here by mistake given L minus 3. So no answer. You can write the answer, original answer. Right. So remaining, we'll try to solve in the next class if possible. If we'll get before the examination. If not, you have to practice. So we are given everything for you. Material is there. And you have the key also, solutions. If you have any doubt in your key, you can ask your teachers or we'll discuss in the next class. Because next class, we have to go for the new chapter. If any possibility is there before the exam, definitely will guide you. Okay. So that's all for today. What we had completed the complete units and dimension chapter with few of the worksheets. Remaining worksheets we'll try to complete in the next class. And this is you can practice for the exam. This is a DPP. You practice for examination. Instead of the question, you can write practice for examination. Daily practice problem. DPP is practice for monthly test. Monthly test 1. Which is scheduled on 1st August. Right? Clear all of you?